Hello everyone. Let's take a look at one more theorem that proves that a quadrilateral is a parallelogram. We're saving this one for last because this proof actually uses one of the previous theorems that we did recently. So again, we're starting with the quadrilateral. I want to prove that this is a parallelogram. And again, what that means, I'm going to need to use the definition of a parallelogram, which is that the sides are parallel to each other. And the given information I have this time is that the diagonals bisect each other. So AC and BD, they cut each other in half. So if I'm going to mark up these segments here, we have our intersection. Let's name that point M. We know that AM and CM would be congruent, and we would know that BM and DM. So that's what it means to bisect. So that's what we're going to start with, and then we're going to show that the sides are parallel. For our proof, let's start with our given information as usual. So it is given that the diagonals bisect each other. So AC and BD bisect each other. As we indicated in our diagram already, if they bisect each other, they're getting cut in half. So then we know that AM is congruent to CM. And then for our other diagonal, we know that BM is congruent to DM. And that's just the definition of a bisector. And in this case, it's specifically a segment bisector. Okay? The next thing I want to do is I'm actually going to pick out two of these triangles and show that they're congruent. So drawing in both diagonals, we actually get four triangles here. It's basically two pairs. So we have this triangle on the left, the triangle on the right, and then the top and bottom. I want to pick out one of those pairs and show that the triangles are congruent. Let's do just top and bottom. We'll do left and right. So I have the two sides, two pairs of sides for these two triangles. I also have vertical angles in the middle. It's a nice, easy, congruent piece to get. So also we know that angle AMB is congruent to angle CMD, and that is the vertical angle theorem. And with that piece of information, we have 1, 2, 3, 1, 2, 3, so we know that these triangles are congruent. So then, triangle AMB is congruent to triangle CMD. And looking at the way that we have this information, a side, angle in the middle, and another side. So the side, angle, side congruence theorem. Okay, so now that I know that these triangles are congruent, I also know that their corresponding parts have to be congruent as well. So the first one we're going to look at is I know that their third pair of sides also has to match up. So AB and CD, those two segments have to be congruent. And CD are congruent. And then we also know that the other angles have to match up as well. So for example, this angle down here, angle BAM, that has to be congruent to angle, let's see, that'll be DCM. So angle BAM is congruent to angle DCM. And for both of those, we're just using corresponding parts. And I'll abbreviate it this time to CP, CTC. So corresponding parts of congruent triangles are congruent. The reason I wanted to look at that pair of angles is because those two angles that I picked out, they are alternate interior angles using AC as the transversal. So if those alternate interior angles are congruent, we know that these two sides have to be parallel to each other. So that's using the converse of the alternate interior angle theorem. So by the alternate interior angles converse, we know that AB is parallel to CD. Okay. So I could go through a similar argument and get this other pair of sides, but the information we have now is we have one pair of opposite sides that are parallel and they are congruent to each other. That was a theorem we just proved recently. So with those two pieces of information, I know that this is a parallelogram. So therefore, ABCD is a parallelogram. And the theorem that we just proved that shows that is opposite side parallel and congruent theorem. So one pair of opposite sides, the one pair is parallel to each other and they're congruent to each other. And that's what we wanted. So in this case, our starting information was that the diagonals bisected each other. In other words, point M was the midpoint for each of the diagonals. And starting with that information, we know that this is a parallelogram.